Good morning, students. How are you all? Fine. When is your chemistry IP exam? Tomorrow. Okay. Okay. So we'll go to up to here we have taken, is it? Message to the co-host. Till shifts reagent. Any doubt is there till here in any of the identification test? Anyone? Yes, Akshay. What is your doubt? Benedict's reagent. Okay. Akshay. Another students. If any doubt is there. Okay. 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 See here actually point is Benedict's reagent, or else I will show you like this. You see, maybe you will understand it better through. There is a copper sulfate, aqueous copper sulfate is there, or let us say copper sulfate is given to you. This copper sulfate will be added with an alkali, sodium hydroxide. So it will convert into cupric hydroxide. Cupric hydroxide. This cupric hydroxide and cupric hydroxide means what? This is like this, OH, OH. This compound will be reacted with this one. What it is? This is let's say like a solution A. This is a solution B. Now these solution A and solution B will be added in equal amounts, that there will be reaction like a removal of water molecule will happen like this, and it results in the formation of Cu, OH, O, C, CH2, COONA, COONA. What is this one? What is this compound is? This is sodium citrate. Sodium citrate. So these two compounds will be added so that water molecule will be eliminated from between them, and you will be getting this compound CH2 COONA. Okay, and finally this is a deep blue colored solution which is ready to interact, to react with aldehyde. Understanding? So here copper is present in a +2 oxidation state. The moment it will react with an aldehyde like C double bond O H with an aldehyde, this Cu2 plus will be converted into Cu plus 1. Cu2 plus is soluble in water, whereas Cu plus 1 is insoluble in water, that it comes out as a precipitate. What precipitate? It comes out as a precipitate, downward arrow. It comes out as a precipitate, Cu2O, red precipitate. Understood, Dhruv? So this is what Benedict's reagent is. Similarly, that means finally this is a compound which is going to react with aldehyde in Benedict's test. Okay, compound Cu2 plus, whatever is there, that will be converted into Cu plus. There is no name for this compound. Particularly, there is no name for this compound. This is a final solution. You can say that this itself is the Benedict's reagent. You remember this much, that is sufficient. Okay, so going to next point, there are some important things we have to observe, like this compound, aromatic aldehydes. Aromatic aldehydes means to the aromatic ring, aldehyde group should be directly attached. That means like benzene ring is an aromatic ring to which directly aldehyde group should be attached. They are called as aromatic aldehydes. Suppose if this compound is there, then CH2 CHO is given. This is not aromatic aldehyde. Understanding? Suppose if compound is like this, CHO, another compound like this, CHO, another compound like this, CHO, another compound like this. These are aromatic aldehydes. They will not give you the reaction, whereas these are not aromatic aldehydes. Understanding? These are not aromatic aldehyde. Maybe aromatic ring is there, but it is not aromatic aldehyde. Aromatic aldehyde means directly the CHO should be attached to benzene ring. Okay, na? So these will give the positive test. Positive test. Like that, you can negative test, positive test, like that. Then next is so aromatic aldehydes like benzaldehyde will not give Fehling's, Benedict's, and Schiff's. If it is not giving Fehling's, Benedict's, and Schiff's, what does it mean? That it will give tolerance. That is what the point. Na? The next point is this is normally we know the compound already, and then this is a compound already we know it, aldehyde. Then this is a special compound. I already told you this is an exception compound, that alpha hydroxy carbonyl compound, and formic acid is also a special compound. May not be they may not be directly aldehydes, but they also will give Fehling's, Benedict's, and Schiff's tests. Okay, na? These are the exceptions. Note points. We have to remember them. Very important. Take down. This itself is a first page, Anand. I think you are joining late and asking first page of lecture like this, na? Anand, did you join late? You should join. You should join on time. By 8:20, you have to keep everything ready, and you should be ready for login. Over. Nothing. Nothing happened. This itself is the first page, eh? Why you people are asking like that? I don't understand. This is the previous page. Okay. Completed. Gender. Very good. So next is a very important test called a haloform test. Haloform test. See, initially what we have done in identification of carbonyl compounds, we have taken a 2,4-DNP test. And from there to identify aldehydes, exclusively aldehydes, we have discussed the 4 tests. That is Tollens, Fallings, Benedict's and Schiff's test. If a negative test is there for these tests, like a Tollens, if negative test is there, but 2,4-DNP test is positive, then you can say that it is a ketone. Then there is a special test, haloform test, or you can particularly call it as an iodoform test when iodine is used. When iodine is used, this test is used for the identification of methyl ketones. This test is used for the identification of methyl ketones, but there are some other compounds also as an exception. They also will give the reaction, but most of the times it is a test to identify methyl ketones. This is the most important identification, or it is the most important application of this test, that is to identify the methyl ketone. This is the only test to identify ketones, but that too limited to methyl ketones. Other ketones, like if any, this is a methyl ketone. Suppose if any ketone is present like this, CH2, C double bond O, CH2, CH3. This is not a methyl ketone. Understanding? There is an ethyl group adjacent to C double bond O. Only methyl should be there adjacent to C double bond O. Only that compound can give this test. This compound will not give, cannot give. Okay, na? So exclusive for methyl ketones. The reagent here is sodium hydroxide plus halogen. The halogen can be chlorine, bromine, or iodine. And both together on reaction, they will form NaOX only, sodium hypohalite. That is why either you can take these two, or you can take directly this one also, because anyway, when you take these two, you are going to get this only. Actually, reaction, what happens is NaOH will react with I2 to give rise to NaI plus NaOI, sorry, not NaI, NaX plus NaOX plus H2O. This is the reaction what happens. So this is a compound you are taking. This is a combination you are taking, and you are going to get this one. And this is a compound which is going to participate in the reaction. Therefore, you can write like this, or directly can write like this also. If you are writing like this, means one more extra step will happen during the reaction. That is this one. Understood? So compounds which have which give positive haloform test are these all the compounds: methyl ketones, then secondary alcohols, then this is also a methyl ketone actually, then this is also a methyl ketone, and then ethanol. Under primary alcohols, only ethanol is a compound which will give the reaction, and then this also has the methyl ketone like this. Thing is like this has the methyl ketone, this has the methyl ketone, this has the methyl ketone, this also has the methyl ketone. These four compounds we can understand that yes, as they are having methyl ketones, they are giving the test. But why these two compounds are giving the test is because this compound, this compound, whatever is the reagent, this is not only giving iodoform test, it is having another behavior also, another property also, that is oxidizing in nature. That means this can also be used as an oxidizing agent. Like in a bleaching powder, you will be having a calcium hypochlorite. That is an oxidizing agent, bleaching agent. That is why the microbes and all will be broken down, and they will be killed because of that oxidizing nature. So like that, here sodium hypohalite will oxidize the secondary alcohol into this compound, NaOX. Will oxidize the secondary alcohol into this compound, and this ethanol also will be oxidized into this compound. That means even though you are taking alcohols, maybe to look like they are alcohols, but as soon as they are added, they are starting participating in the reaction. Ultimately, they are going to form these compounds only, and these are anyway are having methyl ketones. That is the reason why these two compounds also will give the reaction. Understanding? These compounds will be converted into these compounds during the reaction. Simple point, you can write like that. Third and fourth compounds during the reaction will be converted into first and second compounds respectively. And from thereafter, as the methyl ketones are present, they will also be giving the same reaction as expected by methyl ketones. Understood? So write down this page. Very important, all this information is. I am removing some of the students whose names are not proper. That also I will tell you, Gautam. That also I will tell. Okay. First, copy this page. There is a reason behind that, why exclusively we are taking iodoform. One second. Yeah, you can continue. Don't write mistakes while copying. Sodium hypohalite. Completed, Vijender? Next. So this is a reaction, how iodoform reaction, or in fact, haloform reaction will happen. Yes, I will explain. You see, why are we using? See here, I have given iodoform reaction. Why not chlorine or bromine? Yes, when you are using NaOH plus Cl2, you can call it as a chloroform reaction, in which chloroform will be formed. CHCl3 will be formed, like how here iodoform is formed. And when you are using a NaOH plus Br2, bromoform reaction will be, the reaction is called bromoform reaction, CHBr3. Chloroform reaction, bromoform reaction, iodoform reaction. But we do generally iodoform reaction because chloroform is a colorless, that you cannot identify whether the reaction has done or not, whether the reaction has happened or not. Because it should be visible, it should be able to detect by our naked eye that there is some change happening. So there will be no color change here, because chloroform is a colorless compound. Whereas a bromoform, color will be there, but it is in the liquid state. And the color will be there, but in the liquid state. So if color is there, but still in the liquid state, whereas in a iodoform reaction, color is there, yellow precipitate, but also precipitate is formed. That means by both the ways, that is yellow color is there and also precipitate is there. So more clarity or more confirmation, with more confidence, you can confirm the reaction. That is the reason why iodoform reaction is more preferred over chloroform or bromoform reactions. And there is no point that they cannot be used. They will not be used because they are not doing the purpose. The identification test purpose. Otherwise, if it is like a normal reaction, not an identification test, then we can do chloroform or bromoform reaction also. They also will be discussed when we go to carbonyl compounds 12th standard next year. So in the carbonyl compound chapter, chloroform, bromoform reactions also will be discussed. But here it is a structural identification chapter. So recognition is most important here. Understanding? So if you take the compound RC double bond O CH3, it will break here. You see, if this is a n number of carbon atoms, the carboxylate salt it is forming by breaking. This is the one which is giving the carboxylate salt. That is having n-1 number of carbon atoms. One carbon atom lesser carboxylic acid you can prepare. The carboxylic salt is the product. But if you want a carboxylic acid, suppose you want to use for some other purpose, carboxylic acid, not to waste it, then you can do acidification. So actually this is O minus Na plus. This O minus will take the H plus ion and will become OH. So like that, you can get carboxylic acid with one carbon lesser carboxylic acid you will get. Okay. And along with that, this methyl group is the one which will be converting into iodoform. This reaction again we will discuss in very much detail in 12th standard, including its mechanism, how these products are formed. Okay. Right now, our our task is to understand the reaction and to memorize the reaction. Okay. Na? So next, if this is a compound, then what will happen? This sodium formate will be formed, and this will be forming this methyl group will be converting into iodoform. Then these also already I told you, this will be converted into this one and will give the reaction, and this will be converted into this one and will give the reaction as usual expected. Okay. And there is a important note I have written here. There are some compounds looking like they are having methyl ketones, but they are not actually ketones. In fact, they are not carbonyl compounds. Suppose if you say CH3 C double bond O, there is a methyl ketone, but this C double bond O is not a carbonyl group like the C double bond O here, because here this is a functional group that you say it is a carbonyl compound, but here this alone is not a functional group. Immediately to the C double bond O there is a Cl attached. So this is a functional group here, acid halide, acid chloride. So acid chloride, you cannot say that, sir, I will take up to here only, that it should give the reaction. No, this is a functional group that it will not give the reaction. Like that, this is a carboxylic acid, and this is an ester, this is an amide. These all the compounds are not methyl ketones. Basically, they are not ketones at all. They are not carbonyl compounds at all. They are acid derivatives. Okay, and this compound also, all alcohols will not give the reaction to the carbon to which OH group is present and adjacent methyl group is present. Only this type of compound will give the reaction. And that compound, you see, that carbon should have, I will write the condition C here, CH3 CH OH. This may be any alkyl or hydrogen. Understanding? Sorry, this is it is going beyond the tetravalency, na? Like this you can say, or hydrogen. This will give positive result. That means to the carbon to which OH group is attached, there should be hydrogen and also methyl group. Then only this will give positive test. But here you see, to the carbon OH is attached. Yes, like this. Methyl group is attached. Yes, but there is no hydrogen here. That is why this compound will give negative test. Giving a negative test means you have to understand, not giving any test. Okay, na? So copy this page. And while I am explaining, please don't write. Most of the students are doing the same thing again. I can understand it clearly. You wait till my explanation is completed and completely concentrate on the explanation given. Some of the points that I explain during my explanation will not be present in the books. Some like analogies, some similarities, some comparisons, some extra explanation which is given. So that all you will be missing. If you miss that, definitely you cannot build the concept strongly. It will be weaker. Vikas doubt is that is acetyl used when there are two carbons? Yes, there are two carbons. That too, CH3 C double bond O, like a methyl ketone. Yes, ethanol will give iodoform test. Methanol cannot give. Sai? Which one? No hydrogen on carbon with OH. Completed Siddharth and Akshay. Next is a test for amines. We know amines are three types of compounds are taken under amines. They are three types of compounds are there under amines. They are RNH2, primary amine, R2NH, secondary amine, R3N, tertiary amine. So this carbylamine test, first test, carbylamine test is the one exclusively to identify primary amines from other two amines. Primary amines from other two amines. Okay, na? So this is a test, and one more thing, 1 second. I will give you in more clarity. Another point also I will give. Wait. Amines. Amines. Two types. First of all, you can say aliphatic amines. These are all aliphatic amines. You can say. Then aromatic amines are also possible. Aromatic amines are like aniline, pH, NH2, primary amine. pH, NHR, secondary amine. pH, NR2, tertiary amine. Same like an aliphatic, aromatic also, primary, secondary, and tertiary amines are possible. This first point you have to understand. Okay, na? So carbylamine test. Carbylamine test, also called as isocyanate test. Very interesting test. Most of the times, many of the times, repeatedly, it is done in the laboratory. Like I have done so many times. Not only me, those who are in post-graduation level will be doing, or in a research level might have done it so many times. Okay, but to your level, 11th and 12th standard, these reactions will not come for the laboratory. To do in the laboratory, you will be doing for salt analysis, cation and anion. Inorganic analysis you will be doing. Organic analysis will be coming a little later. Okay, if anybody pursues chemistry in future. So also called as isocyanate test. This is a test to identify both aliphatic and aromatic primary amines from secondary and tertiary amine. That means both aliphatic and aromatic primary amine means these two. These two are identified from the rest of the four compounds. Understanding? That is carbylamine test. So if I take an aliphatic primary amine with the reagent is a chloroform plus KOH, or NaOH also we can use. With the reagent chloroform plus KOH, amine will be converted into isocyanide. And these isocyanides, alkyl isocyanide, in the similar way, phenyl isocyanide, are very, very bad smelling or unpleasant smelling compounds. Easily one can recognize even if any person is passing through the department, the laboratory, the lab, chemistry lab, then they can recognize that yes, this guy is doing this, candidate is doing isocyanate test. So that much bad smell it will be giving. So that is a point here. And this reaction is not given by secondary and tertiary amines. That means these four compounds will not give this reaction. Okay, na? Copy this page. Yes, yes, Roshan, correct. Alkyl can be there at other position. Yes, other functional groups can be present. It is to identify amine, na? Other functional groups can be there. They will not interfere. Yes, you will be revising. There will be no teaching again from the teacher side. From the faculty side, teaching will not be there, but you will be revising and you can ask your doubts. Completed everyone, Lokesh? Yes, time will be given. Revision programs are like that only. In 12th standard, we complete the syllabus a little earlier so that you will have enough time to revise. But there, the revision is only possible when only the students will understand the concepts here. Without understanding all these concepts, revision will not be fruitful. This reaction is only given by first degree amines. That is what it is written. What is it written here? Test to identify aliphatic and aromatic primary amines. The next second reaction is a reaction with sodium nitrite and aqueous HCl. Sodium nitrite and aqueous HCl. This test is used to distinguish between primary, secondary, tertiary amines. That means you can distinguish between them actually here. That means all will give the some or the other result. Okay. By that result, you can identify whether it is a primary, secondary, or tertiary amine. So coming to first one, RCH2NH2. This is a aliphatic primary amine. Aliphatic primary amine with a HNO2 or NaNO2 plus HCl. See, one point here is HNO2 is called nitrous acid. Nitrous acid is an unstable compound, not nitric acid. Nitric acid HNO3, stable. But this is nitrous acid, unstable, that it cannot be stored in the laboratory. So therefore, when you want to use it as a reagent during some reactions like this, you will not get it in ready-made in the laboratory. So there itself, you have to prepare. That is called as in situ. In situ preparation means then and there itself. Preparing here, preparing there only, and also utilizing there only. Then and there. At that time, and at that time itself preparing and also utilizing it, using it immediately. So that is in situ preparation. So this HNO2, the unstable reagent, will be obtained by combining NaNO2, sodium nitrite, and HCl. So sodium nitrite and HCl on mixing, you will be getting HNO2, which will go and react with the amines. And primary aliphatic primary amines with a HNO2, or you can say NaNO2 plus HCl, will be giving alcohol and nitrogen gas will be liberated. Nitrogen gas will be liberated. Whereas in case of aromatic primary amines, with the same reagent, you will be getting a special compound called benzene diazonium chloride. Benzene diazonium chloride, BDC. Very important compound. It is a separate chapter itself in 12th standard. Benzene diazonium chloride. This benzene diazonium chloride on reaction with the beta naphthol. Naphthalene with OH is called naphthol. And that too at alpha beta position. OH at beta position is called beta naphthol. Okay. Benzene diazonium chloride with beta naphthol will give orange colored azo dye. Orange colored dye. These are the dyes you already know, na? Like coloring agents for clothes. Na? So different dyes are there. As already I told you, will be discussed in 12th standard. So this combination will be orange dye. Very simple. In the test tube, you will be given some organic compound. To that organic compound, you will be adding a few amount of few drops of reagent, let us assume. And after adding this reagent first, after some time you add the another reagent, that is a beta naphthol. Beta naphthol also will be added. If you are getting finally orange colored dye, it means that the initial compound you have added, initial organic compound you are given is a aromatic primary amine. If you are not getting a orange colored azodye, means it is not an aromatic amine, it is some other compound. Understanding? Then coming to secondary amines with a NaNO2 plus HCl will be giving a N-nitrosoamines. N-nitrosoamines. This N-nitrosoamine is an yellow oily liquid. Yellow oily liquid. Even aromatic secondary amines also will give yellow oily liquid. Only thing is, in place of one alkyl group, you take one phenyl group. So this is also yellow oily liquid. So same result will be obtained by both aliphatic and aromatic secondary amines. Okay, na? You will be getting yellow oily liquid. So formation of yellow oily liquid itself will indicate the presence of secondary amines, aliphatic and also aromatic amines. Okay, take down. Completed? Waiting room. Okay. Shant, next, tertiary amines are there, na? In tertiary amines, they will be giving a different reaction. This is a aliphatic tertiary amine. This is aromatic tertiary amine. Aliphatic tertiary amines with the reagent will form an unstable salt. After some time, it will be decomposing. Unstable means it cannot stay for more time. So it will decompose to give finally yellow oily liquid. That means here also secondary amine is also forming yellow oily liquid. Tertiary amine is also forming yellow oily liquid. Then what is the difference? Here yellow oily liquid is formed directly or immediately, whereas here yellow oily liquid is formed after formation of this compound, an unstable salt, then which is on decomposing is giving a yellow oily liquid. Means some time will be taken here. Okay, that is one difference. Then aromatic tertiary amines on reaction with NaNO2 plus HCl will undergo para nitrosation. So at para position to this group, this is ortho meta para na. So at the para position, this NO group will be attacking. So this is the product, but it will not give any identification like color or anything. Okay. So that is one thing we have to observe. Then there is another reaction, that is a Hinsberg test. Hinsberg test to distinguish between a primary, secondary, and tertiary amines like NaNO2 plus HCl. So first you copy. Okay, I will explain a Hinsberg test also. No, unstable salt means it is not settled at the bottom. Settling at the bottom means a precipitate. Settling at the bottom means it is stable, that it is going and precipitating, and it is going and sedimenting at the bottom. Unstable means that it cannot stay for more time in that form, that it will get converted into some other form. So it will decompose and will be converted into some other new compounds, smaller compounds. Bigger compound will decompose to split into smaller compounds like this. Here one compound has split into two compounds in here. Okay. Then the Hinsberg test, it is used to distinguish between primary, secondary, and tertiary amines. And a Hinsberg reagent is benzene sulfonyl chloride. And along with that, aqueous KOH is also taken. Okay. So how the primary amines will give the reaction is primary amine. See, here primary amine means both aliphatic, aromatic. Here also same thing. Here also same thing. Okay. Na? So primary amines with benzene sulfonyl chloride in presence of pyridine. You know pyridine what it is? In classification of organic compounds, I have given an aromatic compound, pyridine. It is an aromatic compound with a nitrogen. So that pyridine, in presence of little amount of pyridine, the two compounds will react and will form this compound. And this compound is having an acidic hydrogen that it will react with the base. Acid will react with the base and will form a salt which is soluble in water, soluble in base. That means simple logic I will tell you. See, you have taken a glass cube into which you are given some organic compound. You don't know what organic compound it is. To that, first you have added benzene sulfonyl chloride, Hinsberg reagent. And after that, you have added, that means after addition of Hinsberg reagent, you got the precipitate. And when you have added the base as a second reagent, the precipitate bond disappeared and became a clear solution. That indicates first a formation of precipitate with the Hinsberg reagent, and then it getting dissolved, solubilized by addition of NaOH or KOH will indicate that the given compound is a primary amine. If the precipitate is formed, but it is not becoming soluble, it is still present as insoluble only, even after the addition of NaOH or KOH, it indicates that the given compound is a secondary amine. The given compound is a secondary amine. Whereas a tertiary amine will not give the precipitate at all. That means tertiary amine, by the addition of reagent, there will be no change. There will be no change. Then you can identify that, yes, this is a tertiary amine. Got it? Like this, the three amines can be distinguished from one another by using Hinsberg reagent. Copy this page first. Completed? Time taken, time difference. Question? Aromatic tertiary amines. You know, aromatic tertiary amine is this only, na? Last compound. This is not yellow. This is a separate compound. Completed na? Then next. Copy this page. What minus HCl means? Removal of HCl. There will be removal of HCl, H from this compound, H from this compound and Cl from this compound will be removed off to get resultant this compound, this product. Okay, those who have completed can leave. Array, this is a today's first page. How many times you will ask Vijender? This page we have, I have already told, na, yes, this is the first page. Join the class on time. Then there will be no problem. Yes. So take care, everyone. We'll meet tomorrow.